Good morning, students. Hope you went through my YouTube videos. Okay, so in the previous class, we discussed about the different types of experimental designs. Okay, to brief out or to just to recapitulate. Okay, we discussed about the experimental design are going to be classified into two categories. The first one is known as the informal experimental design, and the second one is a formal experimental design. Okay, the informal experimental design where we are not following the statistical procedure strictly. Okay, that's why they are called as the informal experimental designs. Okay, in that we have discussed about before and after without the control design, and after only with the control design, and the third method is that before and after with the control design. So these are the three methods coming under informal experimental design. Okay, then the formal experimental design where we are following very strict statistical procedure or statistical approach. That's why they are called as formal experimental designs. So in this we discussed again the four varieties of formal experimental design. The first one is known as completely randomized design, and that is called as CR design, and randomized block design, that is called as RB design, and the Latin square design, it's called as LS design, and the fourth one is known as factorial design. Okay, all these 7 methods of experimental design we exclusively and in depth we discussed in the previous class with the example. Okay, so then today we'll discuss about sampling design. Okay, sampling design. Okay, in that what you should know what is sampling design. A sample design is a definite plan. Okay, the sampling design or a sample design is a definite plan for obtaining a sample from a given population, and it refers to the technique or the procedure the researcher would adopt in selecting the item for a sample. Okay, this is known as sample design. Okay, once again I repeat, the sample design is a definite plan for obtaining a sample from a given population, and it refers to the technique or the procedure of a researcher would adopt selecting these items as a sample from the universe or from the population. Okay, that is called as a sample design. Sample design may as well as down the number of items to be included in the sample. Okay, the size of the sample. Size of the sample, nothing but how many items are included in a sample. It is called as size of the sample. The sample design is determined before the data is collected. Okay, why it is important? Because before you go for data collection, we should know what is that size of the data or what is the size of the sample. Then we need to collect the data. Okay, some designs are relatively more precise and easier to apply than others. The researcher must select or prepare the sample design which should be reliable and appropriate for his research. Okay, so there are varieties of sample designs. Okay, we must, as a researcher, we must choose a reliable and appropriate sample design for our research study. Then only we are going to get the correct results for our research studies. Okay, then steps in the research design. Okay, the steps in the research design, you should note down all the steps. Okay, so the first step, the type of the universe. Okay, the first step in developing any sample design. Okay, so we must know what is universe. Okay, it is clearly defined that set of objects technically called the universe. Okay, so the inverse is nothing but it is the set of objects, they are called as inverse, that are to be studied. Okay, is called as an inverse. Inverse can be a finite or infinite. Okay, so that inverse, the size may be finite or infinite. So the finite inverse, the number of the item is certain, but in case of the infinite inverse, the items are infinite, we cannot count. For example, we cannot have any idea about the total number of the items in the infinite inverse. For example, the population of the city, we cannot tell exactly. The number of the workers in the factory, they are like the examples of the finite inverse. Okay, the finite inverse is nothing but where we know the number. Okay, say for example, the every city and every turn is city and town is going to be exposed to the number of the population in figures. Okay, that is the exact number, and also the number of workers in the factory, they know exact things. Okay, that is called as the finite inverse. Whereas the infinite inverse refers to the stars in the sky and listeners of the specific radio program and throwing the die, etc. So are the examples of some infinite inverses. The second important factor is sampling unit. Okay, in sampling design, a decision has to be taken concerning to the sample unit before selecting a sample. Okay, sampling unit may be geographically one, such as state or a district or a village. It is called as a sampling unit. Okay, or a construction of some construction unit such as house or flat. It is called as a sampling unit. Okay, so then source list, it is also known as a sampling frame. It's also known as a sampling frame from which the sample are drawn. Okay, the source list means it is a frame from which the samples are being drawn. Okay, that is called as the source list, or it is called as the sampling frame. So if the source list is not available, a researcher has to prepare it. Such the list should be comprehensive, correct, and reliable and appropriate. And it is extremely important for the source list to be a representative of the population as possible. The population is nothing but universe. Okay, universe is nothing but they are going to be classified as finite inverse and infinite inverse. Okay, then fourth item is size of the sample. It refers to the number of items that is to be selected from the universe to constitute a sample. Okay, the universe will be there, it consists of huge quantity, so randomly we pick, okay, 15 numbers as one sample. Okay, so pick 15 numbers from the universe and keep it one side. Okay, then again next lot, again pick some 15 numbers from the universe and keep it in the other side. That is called the second sample. The size of the sample is 15. Okay, because we are drawing 15 components from the population or from the universe or from the mass, that is called as size of the sample. Okay, the major problem before a researcher is how to constitute or how to decide the sample size. The sample size should neither be excessively large nor it is too small. Okay, the sample size should be not too large or not too very small. Okay, it should be optimum. An optimum sample is one which fulfills the requirements of efficiency and representativeness and reliability and flexibility of the study. While deciding the sample size, the researcher must determine the desired precision has also an acceptable confidence level for the estimate. So usually the confidence level is 95%, 96%, 97%, 99% of the confidence level. That is nothing but the accuracy of the result obtained is up to that extent accurate. Okay, at that time we need to go for larger sample size, so that mimics the uh, properties of the population. Okay, then parameters of interest, the next factor, the parameter of interest. It is determining the sample size. One must consider the question of specific population parameters which are of interest. For instance, we may be interested in estimating the proportion of the persons with some characteristics in the population, or we may be interested in knowing some average or the other measure concerning to the population. The parameter of interest is nothing but from the population what we are interested to measure, that is called as the parameter of interest. Okay, for example, consider, so the parameter of interest, for example, we wanted to calculate the average height of the some category of the students, say 10th standard students. We wanted to calculate the average height of the 10th standard student. So the height is the parameter of interest, okay, of the sample size which we have selected. The 10th standard sample size, say 60, that is the sample size, and the parameter of interest is the height. Okay, so that is called as the parameter of interest. So what are the parameters of interest with respect to the sample size? That has to be estimated before we carry out the experiment. Those are called the parameters of interest. Then budgetary constraint. Okay, the cost consideration in carrying out the studies is also most important. Okay, from the practical point of view, we have a large impact about the decisions relating to not only the size of the sample but also the type of the sample. Okay, this even lead to the use of non-profitability sample. Okay, that is nothing but, so when we select a larger sample, okay, the cost involved, okay, in taking collection of the data, okay, we need more time, we need labor, more labor, and the time spent is also huge. Okay, naturally the cost increases. If you select the smaller sample size, okay, the budget consideration will be the less. And also depending upon the parameter of interest, the budget also depends. So if the more parameters of interest, naturally we need more time, we need to spend more money. So we need to estimate what is our budget constraint, what is the sample size is to be selected. Okay, that is to be decided before we carry out our research studies. Then sampling procedure, okay, that's also to be decided in the sampling design. So the finally the researcher must decide the type of the sample, okay, he will use, and it must decide about the technique to be used in selecting the item for a sample. Okay, in fact these techniques or the procedure stands for the sample design itself. There are several sample designs out of which the researcher must choose one for his study. Okay, out of available many research sample designs, he must choose the one which best suits for his research study. Okay, that is known as the selection of the sampling procedures for the sampling design. Okay, so these are all the seven items or the factors to be considered in sampling designs, and these seven factors are also called the steps to be involved or performed or decided in the every sampling design. Okay, then criteria. Okay, then next title we take down the criteria of selecting a sampling procedure. Okay, the following the one thing is that while performing the sampling procedure, okay, one must remember that there are two costs are involved in sampling analysis. okay, the cost of collecting the data and the cost of the incorrect influence resulting from the data. Okay, these are the two costs of affecting the sampling analysis. The researcher must keep in the view of these two causes of incorrect inferences. Okay, via we can call it as a systematic bias or a sampling error. Okay, the systematic bias results from the error of sampling procedure, and it can be reduced or eliminated by increasing the sample size. Okay, and the best causes of responsible for this error can be detected and corrected. Okay, so that is why the systematic bias is going to be eliminated so that it can reduce the sampling error. Okay, to have this a systematic bias, so is the result of one or more of the following factors. Okay, that is nothing but the system bias. It is the error which is occurring in the sampling procedure. Okay, so we are not interested in having this systematic error in our research process. Okay, so then how what are the way what are the ways by which, okay, this system bias will occur. Okay, so we need to understand those. Okay, so first one, inappropriate sampling frame. Okay, the system bias occurs because of the inappropriate selection of the sampling frame. You know what is sampling frame? Sampling frame is nothing but it is the it is the area, or it is the universe, okay, where we are interested to take the sample. That is called the sampling frame. So if the sampling frame is inappropriate, okay, the biased representatives of the universe, okay, will affect or will create, okay, the system bias. Okay, then second one, defective measuring device. Okay, the measuring tool for the data collection, if it is not correct, okay, so that will create an error in the sampling procedure or in the data which we are collecting. That is called as the measuring device is constantly in error. Okay, that's why to conduct any experiment or any collection of the data, we need to calibrate our instruments first before we collect the data. Okay, so that the error which is occurring, that is going to be compensated or eliminated during the process of data collection. Okay, then non-respondents. Okay, if you are unable if we are unable to sample all the individuals initially selected in the sample, okay, there may arise a systematic bias. Say for example, we have selected 100 people, okay, to calculate the average height of those people. There is a parameter of interest height. Okay, 100 samples we have selected. There is a sample size 100. So if the 10 students, if they are reluctant, okay, if the 10 students they are reluctant to give their height, so they don't want me to measure their height. So the sample size is 90, but we have selected sample size is 100. Okay, the error occurs. So we cannot get the average height of the sample size 10, the sample size 100, because only the 90 people are giving, another 10 are reluctant of the sample size. Okay, they are the non-respondents. So those non-respondents create error in the sampling process. Then interdependency principle. So sometimes we find that individuals act differently. So when kept under observation, okay, what they do when kept in non-observed situations. Okay, for instance, if the workers are aware that somebody observing them in the course of work, the study on the bias of which the average length of the time to complete the task will be determined, and accordingly the quota will be set for the piecework. so they generally tend to work slowly in comparison to the speed with which they work, okay, if they kept under observed. Thus, interdependency principles may also cause the systematic bias. Interdependency principle means, okay, when in the shop floor observation, if we inform that workers that we have wanted to collect some information, some data about your working, means they will be very cautious, okay, and their performance is something different what actually they were performing. So that's why we are not going to get the reliable correct data, normal data, okay, during the normal performance. So that's why that is called as interdeterminacy principle. Okay, we need to, while collecting the data, we should not tell that we are observing you, we have been kept under observation. Okay, so that is called the interdependency principle. The nature of bias in reporting data, the natural bias of respondents in reporting the data often cause a systematic error in many inquiries. So there are usually, so the downward bias in the income data collected by the government taxation department. Okay, so the natural bias, okay, in the reporting of the data. Suppose if you ask all the politicians, okay, for the election, assume that they wanted to nominate, give a nomination for the election, so we need to they are expected to declare their assets, the value of the assets, okay, so they declare. So when we ask them to declare, okay, they do not declare genuine assets what they are having, okay, so that is for the income tax purpose. They try to avoid the actual assets, and they define only the limited assets for the government. So this is called as the natural bias of reporting the data. When you ask them to report, naturally the data will be something different, okay, so that is called as the natural bias. For that I gave an example for that, okay, so we need to take care, okay, so the bias, which systematic bias which is going to occur in our research study, it is to be eliminated. So as a researcher, we must think that how we could eliminate during the data collection these systematic bias, so that our point of interest is to get a reliable data rather than the artificially created data. Okay, we want the realistic data. Okay. Mm. Then sampling error. The sampling errors are the random variations in the sample estimates around the two population parameters. Since they occur randomly and they equally likely to be either direction, their nature happens to be compensatory type, and expected value of such error happens to be equal to 0. The sampling error decreases with the increase in the sample size. Okay, the sampling error, as I told you that if you take the lesser sampling, we get a very accurate, not accurate results. So to get the accurate results, we need to increase the sample size so that the sampling error could be reduced. Okay, then sampling error can be measured for a given sample design and the size. The measurement of the sampling errors is usually called as the precision of sampling plan. Okay, if we increase the sample size, the precision can be improved. Okay, so but increasing the size of the sample of its own limitations, the large size sample increases the cost of collection of the data, so it enhances the systematic bias. Okay, so we need to have a trade-off between the sampling between the sample size and the sample plan. Okay, how we can reduce the sample error and how we can reduce the systematic error in the sampling procedure. Finally, while selecting a sample procedure, a researcher must ensure that The procedure causes a relatively small sampling error and helps to control the systematic bias in the better way. Okay, this is what the conclusion of this sampling procedure. Okay, so then we need to discuss about the characteristics of good sampling design. When you call that your sampling design is good, okay, the first one, a sample design must result in truly representative sample. Okay, this truly representative sample is the, so whatever we predict the we interpret the results from the sampling result. Okay, that sampling results will mimic the real population. Okay, that's why, so it results in the truly representative sample of the population. The sample design, second, the sample design was such which results in the small sampling error. So as you know that the sampling error should be minimized, as well as the systematic bias in the sampling process also to be minimized. Okay, the sample design must be viable in context to funds available for the research study. So I told you that the budget consideration is one of the important parameters for selection of the sample size that is to be taken into consideration, and the sample design must attach so that the systematic bias can also be controlled. Okay, so the sampling error and the systematic bias both are to be controlled in our research study. Okay, then fifth characteristics of the sampling design, good sampling design is sample should be such that it results of the sample study can be applied in general for the universe with a reasonable level of confidence. That is nothing but, so the whatever the sample size we select, okay, from the universe, so the determination of the sample size should be such that this must reduce the sampling error. At the same time, it must reduce the systematic bias of the sampling procedure of the research study. At the same time, it must reduce the effort of the researcher. At the same time, it must reduce the time. At the same time, it must reduce the cost. At the same time, it must reduce the cost, budgetary constraints. Also, it has to be satisfied. So then the whatever the data which we interpret based on this sampling procedure, it must realistically represent the population. Okay, it must mimic the population. Okay, then only the purpose of the research would be satisfied. Okay, today we'll stop at this point and take down the questions. Okay, so you need to listen these videos repeatedly and understand all the concepts of the sampling plan or the sampling design, and answer the following questions. Okay, so the first question, what are the implications of sampling design? And what do you mean by sampling plan or sampling design? Next question, what are the steps involved in sampling design? Or what are the parameters or factors should be considered by a researcher to pay attention in sampling, going for sampling design or sampling plan? identify and discuss the factors which creates the systematic bias in the sampling procedure. Next question. What are the criteria of a selection of a sampling procedure? Okay, for this question you are expected to discuss about systematic bias and sampling errors. Okay, regarding that. Then what are the characteristics of good sampling design? Discuss in detail. Okay, we kindly go through all the videos of the research study and tell your friends and your colleagues or those who people really interested to know about the research design. Ask them to view all my research YouTube videos, and ask them to subscribe and ask them to view these videos. Okay, so again we'll discuss the remaining contents of this unit in the next class. See you. Bye.